Good afternoon, pilot teachers, and good afternoon, class. Okay, thank you. Sit down. Okay, our lesson today will see us look at the completion of interpreting scale in the statement, getting to interpret and understand scale when it is given as a statement. And we've already done looking at representative fractions or ratio when scales are given in that form. The last of the way in which any scale can also be given on a map could be in the form of a line or what is known as a linear scale. And today we'll simply look at the correction to the activities for the work on linear scale, because that was given to you for your homework, and then we'll move on. And when we move on today, we are going to look at the three different ways in which we have used for interpreting scale and how we can use those three different ways to calculate distances on maps. So I'd like us to look at, first of all, the correction to the activities that you were assigned for your homework. And there were two lots of activities, of which it was simply construction of linear scales, understanding how to interpret a scale and then using that scale to construct a linear scale or a line scale. Activity 3 or 4, according to your worksheet, you were supposed to look at showing or drawing or constructing a line scale to represent the following representative fractions or RF. And the first one is that of 1:20,000. The second RF that was given was 1:50,000, and the third one is 1:100,000. And if you had to put that information in linear form, this is what you were supposed to have got or done. You check your exercise book and you make the correction. You must use a ruler for you to do the construction. You cannot just guess, because the ruler will give you the accurate division when you construct your scale. So for the scale of 1:25,000, when you construct the line, you need to measure the distance for how long your linear scale would have to be, as long as it included or it showed the first division to tell us what the scale is in terms of in linear form. So for the case of the example given there, if this was a centimeter, the division that is, then the total length of the particular line drawn there will be 1, 2, 3, 4 centimeters. So using the ruler, you measure 4 centimeters or more, but then because you want to have a scale of 1:25,000, it will mean if I used meters to be represented with 1 centimeter, then it will mean for every 1 centimeter, it will be 250 meters. And then when I go 2 centimeters, it will be 500 meters. When I go 3 centimeters, it will be 750 meters. And by the time I reach 4 meters, it will be 1,000 meters. Okay? That's for those students who used meters. Again, we could also draw or construct a scale, but instead of using a linear scale, that is, but instead of using meters, we can go ahead to using kilometers. Our converting is very important. We must know how to convert so that we can get our units correct. So for the first example given in meters, a scale of 1:25,000, in meters, when you do your construction, the division or the distance between the 2 points there should be 1 centimeter, and then you put in 250, and the 250, 500, 750, and 1,000 represent meters. Similarly, you could do this for the kilometers, 1:25,000, and use the kilometers instead of the meters. And when we do use the kilometers, then you do the same thing. You do the converting first, and in kilometers, it will be for every 1 centimeter, it will be 0.25. So if this 1 centimeter here is 0.25, then 2 centimeters will be 0.5. And then 3 centimeters will be 0.75, and 4 centimeters will be 1 kilometer. So your linear scale, you check. If you had used meters, it should be this way. If you had used kilometers, as I have explained. Okay, that's for the first one, 1:25,000. 1 for 50,000, or 1:50,000. Our example on the board is given, or on our monitor is given as in kilometers already. So here goes. For every 1 centimeter, the division that is 0.5 kilometers. For 2 centimeters then, if the scale is 1:50,000, 2 centimeters will be 1 kilometer, 3 centimeters will be 1.5, 4 centimeters will be 2 kilometers, and etc. because the scale is 1:50,000. If I had to do this in meters, then what would 1 centimeter be equivalent to? 500 meters. And then 2 centimeters will be 1,000 meters. 3 centimeters, 1,500, and etc. So you double check, make the corrections. The point to make here is that you must ensure that your measurements are accurate. So you must make sure you put the ruler there to measure the distance from this point to that point to be 1 centimeter. From this point to that point to be another centimeter, and etc. So for the case of our example, we are using a length of 4 centimeters with divisions of 1 centimeter. And then we are looking at how to interpret our representative fraction or ratio correctly, and we are coming up with what 1 centimeter is equivalent to. Okay, and finally for that exercise, 1:100,000, this should be an easy one. It should be an easy one simply because we are looking at for every 1 centimeter, if we had to construct, we measure accurately. For every 1 centimeter, 0, 1, 2, 3, 4, 5, etc., it will be 1 kilometer because 1 kilometer, 1 centimeter is to 100,000 centimeters, or 1 centimeter is equivalent to 1 kilometer. So if we are looking at 1:100,000, our scale would be like this. Simply the division 1 centimeter and 1 kilometer, 2 kilometer, 3 kilometer, according to how many centimeters we have. So you double check and make the corrections. And if we had to use meters, then it will be for every 1 centimeter, it will be 1,000 meters, 2,000 meters, 3,000 meters, 4,000 meters, and etc. Do your corrections for those activities. Okay, then the next exercise, that was 4 or 5 on our worksheet. This time, the scale is given in statement form. You are also required to actually construct and show the scale in linear form. And the question reads, 1 centimeter to 1 kilometer with 50,000 centimeters division. The length of that scale that you're going to construct must be 6 centimeters. So you double check. First of all, check the length of your scale for this question here. Is it 6 centimeters? If it is 6 centimeters, you've done the first step correct. Then the next thing that you need to do, because it's saying 1 centimeter to 1 kilometer, is you simply divide. For every 1 centimeter, you put in 1 kilometer up until you reach 6. So it's the same thing like what we've done, but again in statement form, and see whether we could interpret the statement correctly. So your scale, or your linear scale, should look like this. Okay, it's asking for that 50,000 centimeters division. What does that mean? It simply means between the 1 centimeter, you put in a division or a dot there to indicate that here, this is 0.5 kilometers. Here it will be 1.5 kilometers. Here 2.5. But you do not need to write in 1.5, 2.5, 3.5, because as it is, it will already tell you if your linear scale is drawn accurately. Okay, so it should be like this in your exercise book. And finally, the last one, 1:250,000 with 2.5 kilometer divisions. The length of the scale is to be 10 centimeters. This time, you check, you must have a measurement to 10 centimeters. It must be to 10, 0, all the way to 10. That's the length of the scale. Okay, you are asked to have the divisions with 2.5 kilometers per centimeter. So for every 1 centimeter that you measure, it will be 2.5 kilometers. Okay? 1 is to 250,000. It is simply for every 1 centimeter, it is 2.5 kilometers. So there's no need for you to put the kilometers here, because if we know the divisions and if we know this is up to 10 centimeters and we've divided equally into the centimeters there, then we should be able to end up with 2.5. By the time we reach 10 centimeter, what would be the distance then in kilometers? So if we're going to go 2.5 for every 1 centimeter, this one would be 5 kilometer, right? The next one will be 7.5. By the time we reach 10 centimeters, it would be 10.5. 25. So we double check. Our measurement should start from 0, 2.5 for every division. By the time we reach the full length of our measurement, which is 10 centimeters, we should reach 25. And the figures at the top there, they represent our answer in kilometers. Okay, we double check. Did anyone have any problems or any maybe queries or questions to ask with regards to the linear scale? Again, with the linear scale, the idea is similar to what we have done for the statement and the representative fraction. We must be able to interpret the information first of all. And if we can interpret correctly, then we should not have any problems in knowing what is the scale that we're going to use for the calculation of distance. If there are no questions, we're going to move on now to the next task, and that is getting to recognize one of the reasons for why we need to use a scale. So if we go back to the information that we've covered from our worksheet, we would have noted that there are 2 reasons for why we use a scale on a map. And we found out also from the beginning that the 4 important components of a map includes being able to being able to work out the bearing or directions, being able to interpret symbols and keys correctly from maps, being able to calculate distances using scales, and also being able to know what we are looking at by referring to the heading or the title. And we also note that the reason for why we need to know about scale is so that we are able to calculate distances from one point to the other. And the second reason that is given from our worksheet also tells us that we are able to decide on the detail of the features of the Earth's surface, which can be shown on the map. For the second reason for why we need to know about scale, we are not going to look at, we are going to concentrate mainly on the first reason, and that is using the scale to calculate distances. Okay, now we can already interpret scales. We know how to read the scale correctly from maps. We go ahead now with some practical work, and that is calculation of distance. It says here from the information on our monitor, once a geographer understands the different scales used, the next step is to use these scales to measure distance between 2 points. And there are a number of ways of which you can use for calculation of distance or measuring distance using the scale that is given. From the handout or the worksheet, you will find that the 3 ways that are mentioned are, I'm following the activities now. 1, you can use a ruler. You may use a ruler, and that ruler will measure usually a distance which is a straight line distance from one point to another. You measure the distance, first of all, using the ruler. That is a straight line distance I'm referring to here. And then you need to look at the scale. Using the scale, then you calculate the distance of the particular area that you're supposed to calculate the distance of. So the first part is easy, using a ruler. If you do not have a ruler, you may use what we call the edge of a paper. Any piece of paper will do. You find the 2 points or the points that you are calculating the distance of, and then you get the paper, you put it along those 2 points. You get the piece of paper and put it on your linear scale that is on the map, and then you calculate or you work out what the distance on the ground will be. If there is an area that you are supposed to calculate the distance of, and you find that that area is not a straight line, you cannot use a ruler, because with the ruler cannot bend. The ruler is a straight piece of equipment or instrument. So a piece of paper might be a little bit accurate. And using the piece of paper, what you can do is that you subdivide that particular curve into straight lines. So you make subdivision. Say, for example, I subdivide now so that I have straight line distance to actually work with. And then once I've subdivided the point that I'm supposed to calculate the distance of right around in a straight line, I can use a piece of paper, and then from that piece of paper, I work out each subdivisions and I measure or mark on my paper until I complete the full distance. Then a straight line distance I would have on my piece of paper after I've done the subdivisions and I've measured, I will put this piece of paper against my linear scale to measure the distance, or I will use a ruler to measure the distance using that piece of paper, and then I convert using the scale that is given. That's the second method you could use for calculation of distance. But with a straight line, a ruler and a piece of paper would be good enough to calculate the distance. The third way in which we can use for calculating distance that we are going to do some more work with will be a more accurate way of calculating distance, but instead of using the piece of paper, especially on curves or lines that are not straight, by using what we call dividers. A divider, if you see one, it looks like a compass, but a compass is the one that you put the pencil in and you draw the circles with. A divider has two sharp points at the end with no place for you to put the pencil in. And we're going to use dividers tomorrow, so you will be required, or you are asked to bring your dividers tomorrow so that we can use the dividers to calculate our distances that are not straight line. Okay, now let's look at some activities and its measurement and measuring of distances, that is, or calculating of distances. You have the atlases in front of you. I'd like you now to use the information on page 10 and 11 of the atlas to do the following calculation using the scale that is given and using the ruler or a piece of paper to measure the distance from the different points given. The first activity, for you to calculate the distance from Leh to Kainantu. I'm talking about the straight line distance, that is. So first activity, calculate the distance. That's on page 10 and 11 of your atlas. The distance from Leh to Kainantu. Number 2, calculate the distance from Karkar to Kimbe. Number 3, calculate the distance from Kavieng to Daru. Here we are looking at straight line distance, so it should be easy. All you need to do is you get your rulers or a piece of paper, use the scale of that map that is given page 10 and 11, and show your working out in your exercise book. Number 4, calculate the distance from Wewak to Lorengau. And number 5, the distance from Port Moresby to Leh. Okay, we'll go back. Question 1 again, the distance from Leh to Kainantu. Number 2, the distance from Karkar to Kimbe. Number 3, distance from Kavieng to Daru. 4, Wewak to Lorengau. And 5, Port Moresby to Leh. Okay, a word of warning: when you are doing your calculation of distance, make sure that your papers or your atlases are flat on the desktop. There should be nothing at the bottom of them to alter the distance, and try to be accurate as possible as you can. And also don't forget to use the scale of the map that is given. And show your working out. Don't just write your answers in your exercise book. While you are doing that, let me just check this one here. Okay. Did you pick up the correction that I said you were supposed to have done?
Yeah.
Okay. So you had 1 is to 25,000. If you wanted to change that to kilometers, it will be 0.25. Okay, that means for every 1 centimeter here, it's 0.25. By the time you reach 2 centimeters, 2 centimeters here, it's 0.5. Okay, that's it. So you have to just check and move them a little bit. Okay, I'll check this one. You want to 50,000 point. So this one again, it's 1 centimeter. 1 centimeter for 500 meters. So you've gone 2 centimeters. Can you see that?
Yeah.
Okay, so you've got to make the correction for this one too. 1 to 100,000. This one is no problem. No problem, but you are not accurate. You see your measurements, they are not accurate. You need to be accurate because that's what I will be marking when I give you the test. Okay, this one here is 1 to 1. This is okay. And this one here, 2.5. So this is okay. Yes. The divisions are okay. So that means I'll go back again and maybe how about the explanation today? Were you able to understand what I...
Can we go over it later?
Sure.
The whole class?
Yeah, we can go over it all over again, yes. Because this is very easy. Yeah? All it's saying is that if you are asked to draw us a linear scale of 1 is to 25,000, that 1 will always represent a centimeter. So that means it's telling you how many centimeters will be equivalent to how many of whatever unit you're using. That's all. So if it is 1 centimeter, how many centimeters are, what is this equivalent to in terms of 1 centimeter? It will be 0.25 kilometer. So for every 1 centimeter, 0.25. And then another 1 centimeter, which is 2 centimeters now, it will be 0.5 and so forth. That's all. All of them done? Not yet? Okay, don't just write the answer because you might be asked to go and do the calculation on the board. So get your working out so you're prepared when you're giving the answers. Okay, maybe I should go through this with you. Lay to kailan to. This ruler is better. Where are we from? Lay. Kailan to is right here. Right in the middle. 2.567, 2.7. Okay, you got 2.7 there? Okay, Karkar to Kimbe. Karkar to Kimbe will be right in the center of the island. 9.2. Get 9.2. Okay, what were the other two? Lay to Kavieng to Daru. $25. Oh, sorry, it's 22.5. 22.5. We work to Loringa. Is 8.9, 8.8. 8.8. Okay, and the last one? What must be too low? 6 point. It's about 6.1, yeah. Okay. So now, 1. What is the scale of that map? From our book is supposed to be, the TV is so, that's a really good question. We'll just use our scale from the book instead of from the monitor. Okay, we'll check our answers so that at least we can go ahead to doing some more practice for our homework if we are not confident with the calculation of distances. Okay, we'll start off with the first of the calculations. You got to know exactly what you're supposed to do to find the answer. So for our first question, it wants us to look at the distance, calculating the distance from Ley to Kainantu. We are going to use the scale which is given from our atlases because that's what most of you are using. So the scale from the atlas, that's what we are using for our answer to these particular questions. Okay, we'll have our friend here to explain to us how he got his answer for the first question, the distance from Ley to Kainantu. Where's our microphone? You want to show the working up on the board or here will? Okay.
Firstly, I got my ruler and measured it from Ley to Kainantu, and I got 2.6 centimeters, and then I looked at the scale, and it was I got my answer 2.6 centimeters is between 100 and 150 kilometers. So I subdivided my scale into 2 centimeters equals 10 kilometers, and I got 130 kilometers.
So your answer?
So my answer is 130 kilometers.
Okay, we all double check. Did we get our answers about 130 kilometers from Kainantu to Ley? Yes. Okay, then if we got our answer similar to what is given there or exactly 130 kilometers, then we have done the right thing. So if you look at what he's used here, he's actually used the linear scale to find the distance between Ley to Kainantu. So what he did, first of all, he got a ruler, measured the distance from Ley to Kainantu. Another point that you need to remember when you're calculating the distance is to make sure that you put the ruler measurement from the middle of the point you are supposed to measure the distance of to the middle of the point you're supposed to measure the distance to. So if it is Ley to Kainantu, both of those areas are represented with dots. And so that we are closer to, in terms of our measurement of distance, and we are getting our answers very close, we measure from the center of this dot to the center of the other dot. And when you measure from the center of the dot to the other, from Ley to Kainantu, you would come up with about 2.6 centimeters. But 2.6 centimeters is not our answer. According to our scale, if we used the scale given there, it is a linear scale. And the scale, not only is it given in linear form, in what other form is it also given according to our map? It is in a statement. Is it only a statement and linear scale given? No, it's also given as a ratio, and that is representative fraction. So you see, the 3 different ways in which scales can be shown are already given on our map there. He used the linear scale. So what he did was he subdivided the divisions on the linear scale that he's got there. And if you put the ruler on your linear scale, you will note that for every 1 centimeter, it is equivalent to how many kilometers? 50. Okay, so we're going 1 centimeter, 50, 2 centimeters, it is 100, 150, and etc. You double check. That is shown on the linear scale. So what he did there was he measured the distance. It was 2.6, and then he got the 2.6 and he put it against the linear scale, only to find that when he put the 2.6 on the linear scale, the answer was not sitting exactly along where the divisions were. Rather, it was in the middle. And he said it was between 100 and 150. So he went 1 step further. He subdivided between the 1 centimeter that was, and he found out that for every 2 centimeters, it was equivalent to 10 kilometers. And when he did that, he was able to come up with 130 kilometers for his answer. Okay, that's one way of finding the distance. The next way of finding the distance, knowing what we've got here already, is we can use the representative fraction given. And the representative fraction given is 1:5 million. So that's the scale of that map, 1:5 million, which is the same given on a linear scale of 1 centimeter to be represented by 50 kilometers. Okay, what needs to be done next is that he's found the answer as 2.6 centimeters on the map. If we had to use the centimeters, the same unit too, the scale of 1:5 million is the same as 1 centimeter is equivalent to 5 million centimeters on the ground. So if he had to use the cross multiplication calculation, then all he needed to do was 2.6 is to x, because he wants to find the distance in kilometers, that x here. So he will simply multiply 2.6 times 5 million. Can we all check now our calculators? And we divide that by 1, because it's over 1 there. So let's check our calculators. 2.6 multiplied by 5 million. And what would be x, which is our answer in kilometers? 113 million. 13 million? Okay. And it will be in centimeters. So if we want to find or convert these centimeters to kilometers, what do we need to do? We divide by 100,000. So we divide this by 100,000 to get our answer into kilometers. We cancel out the zeros. And x then is 130 kilometers. Isn't that the same as what we've given for this calculation here? Yes, so that is another method we can use for the calculation of our distance. Okay, since we have already we are running out of time, that is, I'm going to leave the rest of the other calculations for us to make sure we have our working out too, and then in our next lesson we will present some of those answers with the explanation of each of those. Okay, so that means our homework is to ensure that we complete calculating and showing all our working out for the calculation of distance from Karkar to Kimbe, and also distance from Kavieng to Daru, Wewak to Loringau, and Port Moresby to Ley. You'll need those atlases, so you can take those atlases with you, but I'll have them returned or collected. Class captain, if you can collect all those atlases at the end of study period this afternoon. Okay, that's the end of our lesson also. Class, if you can now stand up. To the pilot teachers, our keyword for today is distance. That's for lesson 7. Good afternoon and thank you, class.